Hello guys, welcome to my channel. In this video I will show you how we can use FreeCAD to prepare geometry to be used in cfMesh, so that in cfMesh we will prepare the meshing for open form analysis, where in this case I will show you how we can prepare 2D geometries for open forms. So first we launch the FreeCAD software. And to prepare the 2D geometry, we have to start with a new files, and we will be working in the parts workbench. So first, the geometry that we are going to develop is in the form of cubes. So this is the cube. So we use the middle button to rotate and adjust the size of the cube by clicking on any surface of the cube, and then we can start changing the length, width and the height of the cube. So let's say I would like to take this cube, which will be 100 meter length, and then in terms of height I will have 40 meters. Then the thickness will be just 1 meter. So this is the cube or the box will be used as a fluid domain for my CFD analysis. The second geometry will be cylinders, which is in this case I would like to model vortex shading behind a circular cylinder. So I will prepare a cylinder. So I have my cylinder there, and the radius of my cylinder will be 2 meter, and the height, so if I can hide this, and then the height will be 1 meter. So this is my cylinder. So we will model the flow past the cylinder at Reynolds number of 200. So we will, after that, we'll capture the vortex shading or common vortex frequency developed behind this cylinder, and surrounded by 4 square blocks. So if I show this cube, sorry, here should be, the width should be 20 for my cylinder. So as we can see here now, the cylinder is located somewhere there, which is we must transform it 20 meter in the direction and 20 meter in the y direction, so that it will be resides somewhere there. So we take the cylinder there, and then we click there to adjust the locations of this cylinder. Let's say, okay, I put it there 20, and then I put another 20. is it my okay, sorry, this should be 40 meter. So my cylinder, so I would like to place or adjust the locations on my cylinder to be somewhere there. Okay, now we can see that the cylinder is located now moved or located somewhere there. So since I not only model the cylinder, but somehow I would like to put a rectangular blocks, or 4 rectangular blocks surrounding this cylinder. So now I have new cubes. So is this located there? The size of the cube will be the same size as this the diameter of this cylinder, which is the radius is 2. Now the diameter will be equal to 4 meters. Then we take the thickness as 1 meters, and its height also equal to 1 meter. So now I would like to place it somewhere there. So I have to change the location of this rectangular blocks, and yeah, we put it there. Okay, it's look nice now. Then I would like to make an array, a polar array, so that I will have 4 blocks, rectangular blocks surrounding this cylinder. So I will move it into the draft workbench, where in this case I have this icon there, which is to create a polar or rectangular array from a selected object. So this is my selected object. Then I click it there, and so this is the type of array that we want to generate, so whether it's ortho or polar. And then the number of polar there will determine how many blocks that we want to have in 360 degrees. So as we can see now, we have the polar or the block which is resides somewhere there, which is something that something wrong with the making of this array. So this is actually due to the center of this array that was used before, which is we take the center which is located at 0, 0, 0, but it's supposed to be located somewhere there. So to change this, I can put it 20 there, and then 20 in the y direction as well. So now as we can see, it's moved to the correct location as what we intended to have. So now I open up the cubes. Alright, this is roughly the location of my structures where I would like to calculate or simulate the flow around these 5 objects. So next is to prepare the boundaries or surfaces of each geometries that we have. So I think first let me start with the cube. So I hide this cylinder and also the other things here. So I just start working with the cube. So we select the cube, and still in the draft workbench, so I can use this buttons or icon to explode my solid bodies into its surfaces or faces. So if I click there, so now the whole structure is now exploded to their respective faces. So let's take the face number 1. So this will be our inlet. So I will rewrite this or rename this with the inlet. And then where is this? So this is located at the back there. So I rename it with the outlet. So where is this? So this will be the bottom, the floor. So I call it as the floor. And then this will be the ceiling. And then this will be the left surface for the box. Sorry, the right surface for the box. And then this will be the left surface for the box. So now we have all of this ready, so we should be happy with this now. So now let's open up the cylinder. So this is my cylinder. Maybe I can hide this first, so we can focus on the cylinder only. So similar to the cylinder, so we explode the object into their surfaces. Now I have this. So this will be my cylinder surface to be used in the 2D calculations. So this will be the left surface of the cylinder, and then I have the right surface of the cylinder. Alright, so now we have that done for the cylinder. So now a similar thing will be developed for the rectangular blocks. So in this case we have I think we can combine. So if I take this and then we separate it, so this is the compound. So this is all the compound, and then we separate it like that. So I have number 1, number 2, number 3, number 4. So for the solid number 1, we explode it again. And then for the solid number 2, we explode it again as well. Solid number 3, and then we do the same for the solid number 4. So in this case, I would like to take this this surface, this surface, this surface, this surface, which will be our rectangular. So I will take this, and that, and then I will have that one. So we select all the structures now. So can we combine this? Right. So then I can call this is as my rectangular blocks. And then this one, sorry, 1, 2, 3, 4. So this will be the left. So this will be the left surface of the block, and then we merge this to one name, and then we call it this as the right surface of the blocks. All right, now we have all of this geometry define the surface or boundaries, and then we save it. So I can call it as the cylinder 2. So for the cfMesh and for 2D simulation, we just need the surfaces as shown here, where the side surfaces is not need to be models for 2D analysis, because these surfaces will be defined automatically by the cfMesh as the top empty surfaces and bottom boundary bottoms empty surfaces, and this will be done automatically in the cfMesh. So alright, now when we have this, what we have to do next is to save each of these boundary So we have to export this as the STL mesh, but in the ASCII format of the STL. So in this case, if we are using FreeCAD, so I have to do this a bit manually. So to use AST for the ASCII STL mesh, because in OpenFOAM, OpenFOAM only working with the ASCII form of the STL, so I have to use AST file instead of STL. But later on, since the OpenFOAM cannot read AST, so later on we will convert the AST file into the STL file. So we will see this later. So I will save this the boundary, the first boundary inlet using .ast. So I export this the outlet, and then we will do the same to all these boundary surfaces. Now I have export all the boundary surfaces into the ASCII file of this ASCII version of STL as shown here. So now is to work with the this file, where we will open each of these files and we'll look how these files looks like. So we will see this in the next video. Thank you very much.